Welcome back. In today's video, we are going to talk about scatter plots and a line of best fit, and we are going to use the graphing calculator to determine the equation of a line of best fit. So to start, let's talk about what a scatter plot is. It is values, x and y values, plotted on a set of axes. So we've got an x-axis and a y-axis. So here's an example. I've got my horizontal x-axis and my vertical y-axis. A scatter plot shows correlation, or it could possibly show that there is no correlation. So here is a scatter plot for this data. The table is showing approximate percent of students who sent college applications to 2 colleges in various years after 1985. So year 0 would be 1985. That is 0 years after 1985. Then 3 years later is 1988, then 1992, and so on. And here's the percentage, the approximate percentage of students who sent college applications to 2 colleges. So I've plotted each point 0 years after 1985, about 20%, 3 years after 1985, about 18%, and so on. Now notice that I've also done some labeling on here. It's important to label what each axis means. So X, the years after 1985, so I've labeled that's the years after 1985, and I go from 0 to 15, so I have 0 to 15 counting by ones. Then the y-axis is the percent of students who sent 2 applications, so I labeled this one as the percent of students. And I needed to go as high as 20, so I went from 0 to 20. And this one's a little bit shorter, so I counted by 2. So 2, 4, 6, 8, and 10. And then once I plotted all of the points that I was given, I put a line through that kind of split through the data. And that is my line of best fit. Now, what does this line seem to suggest? It suggests that fewer students send applications to 2 colleges as time passes. Fewer students send applications to 2 colleges as time passes. Okay, so this has a correlation and it's trending downward. So this is a negative correlation. So I'm going to make a little note here that if your data seems to be doing this, there is a negative correlation. If your data is doing this, there is a positive correlation. You could have data that's just kind of in a horizontal line like this, and that is constant correlation. Or you could just have data that's just all over the place. And that would say there's no correlation, so none. So you can have positive correlation or negative correlation. You could have constant correlation, or you could have none. There's no correlation. Now, how well does this line fit this data? I would say it fits very well, which means there's a pretty strong correlation happening. This is a pretty small set of data, but I would say it's a pretty strong correlation. The line fits well because the data is pretty close to the line. So it fits well because the data is close to the line. Now, if we started getting data that was maybe showing still a negative correlation, but the data was spread out around that a little bit more, I would say it didn't fit quite as well, so maybe there's not quite as strong of a correlation. We're going to write a prediction equation, or it's also called a predictive equation, for the data and decide what the slope and the y-intercept mean. Now, here's how we're going to do this. We are going to use a graphing calculator, in this graphing calculator, I'm going to use the Stat button, and I'm going to edit, and I've got list 1 and list 2. Now, I've already got these numbers in as my two lists, but what if I've got stuff in there that I don't want there? I'm just going to go up and highlight list 1, hit clear, nothing happened, but when I go back down, it goes away. So now I just need to put that back in. And my list is in there. Now sometimes a student might open up these lists and L1 is just not even there, and it's just L2 and L3, and that can be fixed, but what if we just put our lists in L2 and L3? That's going to be okay. So here's what we're going to do now to get our line of best fit. So we are going to press Stat again and go over to Calculate. Option 4 is linear regression, AX plus B, and that's the same as MX plus B, so slope and y-intercept. So we're going to choose option 4. You can go down and highlight it or just press the number 4. Okay, now this is going to call up list 1 and list 2. What if your calculator started with list 2? I've seen it happen. So what you would do is press second and then list 2, and now it's the X list is using list 2, and then you would do the same for list 3. I'm going to have to go back and change that to list 1. I don't want both of those, so I'm going to have to clear that. So second and list 1. So I'm showing list 1 and list 2, and I'm just going to hit enter, 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 and now I'm on calculate. One more enter, and there is my slope and my y-intercept. So the predictive equation is y equals negative 0.4476x plus 19.19. That is my predictive equation. What do the slope and y-intercept mean? So the y-intercept is the starting point. So it's saying that we really started with 19.19%. Now we saw up here at 0 we were at 20%. And that's okay. The line of best fit doesn't necessarily hit every point exactly. And it's also saying that for the slope we are decreasing by, pardon my whiteout here, it is decreasing by 0.44, and I got back to this a little bit too early. That whiteout's still a little bit wet. 0.4476, and that's what happens when you say a wrong number, when I write a wrong number. So it's 0.4476% that it's decreasing by per year. Next, we will predict the percent of students in 2010. This only goes up to the year 2000, 15 years after 1985. So what might that percent of students have been in 2010? So y equals negative 0.4476 times whatever year number 2010 is, plus 19.19. Okay, so we started this study in 1985, so 2010 minus 1985 is 25. So 2010 would be year 25. So negative 0.4476 times 25 plus 19.19 is 8. So we're going to say it would have been about 8%. If this line holds true, so if this trend, this decreasing trend holds true, then we would estimate that in the year 2010, it would have been about 8% who would have turned in 2 college applications.